Ever wondered how a small pixel in a raster dataset can influence and be influenced by its neighbors? This intriguing interaction is the essence of focal operations in raster data. Dive into the world of focal operations, a world where each cell or pixel in a raster dataset isn't an isolated island but part of an interconnected neighborhood. In this fascinating realm, the value of each cell is a function of not just its own value, but also the values of cells around it. So, how does this process work? It all starts with a moving window, a neighborhood that shifts with each cell as it is processed. Imagine a spotlight moving across a stage, illuminating different actors as it goes. In the same way, this moving window shines a light on different cells and their immediate neighbors. Output. The configuration of this neighborhood, its size and shape, plays a vital role in determining which cells will be factored into the calculation of each output value. The most popular configuration is a 3x3 cell neighborhood. This includes the cell in question and its closest 8 neighbors, forming a neat square. The first step in focal operations is to position this 3x3 neighborhood on the raster dataset, with the cell to be processed at its center. Output. Next, a function is applied to the values of the cells within this neighborhood. This function could be a simple arithmetic mean, a maximum or minimum value, a sum, or even a more complex statistical operation. Once the function is applied, the result becomes the new value for the central cell in the output raster dataset. Output. This process is then repeated for each cell in the raster dataset. The moving window shifts, the function is applied, and a new value is calculated. In essence, the focal operations process transforms each cell's value in the raster dataset based on the values of its neighboring cells. It's a dance of values, a ripple effect that spreads across the entire dataset. To summarize, focal operations involve a moving window or neighborhood that shifts with each cell in the raster dataset. The size and shape of this neighborhood determine which cells are factored into the calculations. A function is applied to the values of the cells in the neighborhood, and the result becomes the new value for the central cell. This process repeats for each cell, creating a ripple effect across the raster dataset. Understanding focal operations offers powerful insights into the interplay of data in raster datasets. It's a tool that helps reveal patterns, trends, and relationships that might otherwise remain hidden. Remember, in the world of raster data, every pixel counts, and every pixel is a part of the neighborhood.